the conditions for performing a t-test are that you have to not know what sigma 1 and sigma 2 are. Let's take a look at how it works. So one thing that's a little different is the standard error formula. So we're going to use this S here as the standard deviation of the sampling distribution, and it depends, the formula we use, on whether we think the variances are equal or if they're unequal. So if they're equal variances, we will use this formula here and this approach, but if they are unequal variances, we'll use this approach. Okay, I'll try it on an example here. It says, a study published by the APA, American Psychological Association, in the journal Neuropsychology reports that children with musical training showed better verbal memory than children without the musical training. The study also showed that the longer the musical training, the better the verbal memory. Now you want to duplicate these results because in science and statistics, if results are having some validity to them, they should be reproducible. So you could do a verbal memory test with a possible 100 points and give that to 90 children. Half of the children have musical training and the other half do not, and they act as the control group. So the 45 students with training had an average score of 83.12 on the test, and a standard deviation of the sample is 5.7. Then if you have 45 students in the control group and they have an average of 79.9, it's a little bit lower. They didn't have the musical training, and their standard deviation was 6.2. At the alpha level of 0.05, is there enough evidence to support the claim that children with musical training have better verbal memory test scores than those without? Alright, so let's say mu1 represents the population mean score for the musically trained kids. And I'll let mu2 equal the population mean score for the untrained group. Alright, what they are claiming here is that mu1 is going to be greater than mu2. So having the training will significantly increase their scores. That's the claim. The opposite would be less than equal. This one is HO, and the claim is HA this time. This is going to be a one-tailed test, and it's going to be a right-tailed test. Let's find the ZC that goes with this right-tailed test. They say use an alpha level of 0.05. So this is 0.05. And since it's a TC, we have to use the degrees of freedom. So according to the guide here, the way we get the degrees of freedom, it matters whether the variances are equal or not equal. It says, assume the population variances are equal. So if they're equal, we'll follow this approach. So I have to actually let my degrees of freedom be given by this. N1 plus N2 minus 2. Let's do that. Alright, so N1 was 45. N2 is also 45. So we get 88. Now the closest ones would be this 1.664 and the 1.662. I'm going to go with this one because less degrees of freedom would be worse. We'll go with the worst case scenario, 1.664. Great, now we just have to find the T star. Now, according to the formulas here, because the formula is so big for the standard error, it's shown here as two parts. So you could calculate like all this first. Calculate all this. And then when you get your answer to that, you could just put it into the denominator of your formula. So let's try that. But let's find that answer, and then whatever we get, we'll plug it into the denominator up here. So N1 is 45. S1 is the standard deviation of sample 1, which is 5.7. N2 is 45. And our other standard deviation is 6.2. And then we'll do 45 plus 45 minus 2. And we'll have this. You have the option of just doing it piece by piece. Like maybe you just want to do this part first. Calculate that and then replace it with just a single number. Okay, so I get 3120.92 over 88. Okay, we'll calculate those. I get 1.26 for the whole thing. Alright, now that I have that, I can go back to my T star formula and just put that in for the denominator. And then in the numerator, we'll subtract our sample means, which was 83.12 and 79.9. I get 2.56. So am I in the rejection region with this? Yes. We would be over here. So I will reject HO, which means that we don't like it. And we do like the claim. So the claim was that having the musical training did make a difference. According to what I found, it's true. At the 0.05 significance level, there is enough evidence to support the claim that the mean scores are different. for musically trained and untrained students.